SciCast and TechCast both share a vision that forecasting should be accountable. That is, you should be making specific forecasts and keeping track of which ones you get right and which ones you get wrong. And that enables you to do many powerful things, but fundamentally it enables you to see how well you're doing and improve over time. SciCast uses a prediction market, which is a different approach from TechCast, even though we have the same goal. And since some people are not familiar with prediction markets, I want to take just 10 minutes at the beginning to introduce the whole audience to prediction markets and to SciCast's market in particular, before going into a deep dive on cybersecurity, where Dan Geer will talk about the importance of forecasting in cybersecurity, and then we'll move on to the future of AI with Robin Hanson. If I could have the next slide, please. For the past 4 years, this is a very exciting slide. For the past 4 years, we've been funded by IARPA to develop a new kind of prediction market and test it. And for 2 years, that's been on science and technology forecasting. We're very grateful for their funding, and I do just want to say that my opinions here are my own and not theirs. Next slide. The fundamental difference between a prediction market and a survey is that market participants have finite resources. In our case, when you sign up to SciCast, we give you 5,000 points. And every time you change the market's estimate, you have to invest those points. If you've moved it in what turns out to be the right direction, and we'll know that when the question resolves, then you will get extra points, and over time get more influence. And if you've moved it in the wrong direction, you lose your investment. So over time, the market allocates resources to the people who are good at answering the kinds of questions we're asking. That means that if you're a forecaster, you might want to skip questions where you don't think you know more than the average forecaster. But managing points is difficult for beginners. So by default, we start them at this interface, which looks like a survey. In this case, I have picked a particular question: will any government officially accept a digital currency by the deadline? In our prediction market, all questions have to have a deadline, a use-by date, so that we can evaluate them yes or no. It's told me the market thinks this is somewhere in the 40 to 60% range, and I think it should be more likely than that. So I've selected likely, 60 to 80%. This also may be new to people who aren't used to our forecasting. We're always asking our participants to give us a probability or an estimate of the chances. And then we score over time by how close the forecast was to putting 100% probability on the actual outcome. I would then submit my forecast, and the system would decide, based on how certain I was and what it knew about me, especially my past performance, how big of a trade to make in the market behind the scenes. Next slide. The market then puts my forecast together with everyone else's to give a familiar stock ticker line of the market's forecast over time. And it has done generally very well. Here's 2 examples of questions where it did well and what it looks like. We asked for the Axion dark matter experiment, would it have a positive result by the middle of last year? Forecasters were always suspicious of this. They were skeptical, that is. The forecast never moved above 50%. Maybe these will be detected, but not by that time. It moved around in the 30 to 50% range, and then about 2 months before the deadline, the market decided, no, this just isn't going to happen. We're not seeing all the preliminary results or information that we would need to see in order for this to be positive by July. And that turned out to be correct. Similarly, we asked whether Amazon would adopt Bitcoin by a certain time. The market immediately said, this is unlikely, but not impossible, somewhere in the 10% range. But if you look at the trace on the right, you can see the market reacting to news over time. Something would make Bitcoin more prominent, and this was a time period when it was very much in the news. The probability would go up, but there'd be no further movement, and it would settle back to baseline. So these are what successful forecasts look like. The market fairly quickly decides, it takes a strong position and holds it. Next. I'm not going to go into a lot of detail on this one. A little bit of extra information that quantitative forecasting methods have been found to be better than qualitative forecasting methods, particularly for science and technology. And there was a very nice analysis done by the Twardy group a couple of years ago. Prediction markets have been compared to surveys in many fields, from presidential elections to horse races, and found to be as good or better. And they have a special advantage when your information cycle is much faster than your formal survey cycle. Prediction markets can react very quickly. And that's a substantial advantage if you're trying to get the best time averaged forecast. And I think that's all we need for this slide right now. Anyone wanting to go deeper can ask questions on Twitter or on the GoToMeeting app. Once our forecasters get familiar with survey mode, most of them switch over to what we call power mode. They've learned about points and how to manage them and how to avoid the common mistakes of putting too many eggs in one basket. And they choose the power mode interface. Here we have a question on the amount of digital information being produced. It's a multiple choice question. So I've selected one particular answer bucket. Said, oh, the probability of that one is currently 25%. I'm going to move it. And you can see the word debit, 0 points, under the middle. This interface lets me move the market to wherever I want to, but the farther I move it, the more it's going to cost me. So I have to be very, very sure in order to move it a large distance. And that kind of immediate tie to finite resources often helps people be better calibrated. I can be more confident in my forecasts when I don't have anything at stake. But often when you put money or even virtual points at stake, people say, well, you know, now that you say that, I can imagine several ways where this could go wrong. All right, next. IARPA did not fund us to create just another prediction market. Most of what I've said before applies to any prediction market. Finite resources, resources moving to the people who are doing better over time, and those incentives to speak loudly when you know something and hold back when you don't apply anywhere. But our prediction market in SciCast lets forecasters relate questions to each other. This is new, it's different, and it's powerful. And Dan in particular is going to talk about how it might be useful in cybersecurity forecasting. SciCast forecasters can take one question and say, you know what, this depends on the outcome to another question. They can make that link and then estimate the conditional probability or the correlation between these two questions. So for example, that Bitcoin question, you might think Amazon's unlikely to adopt Bitcoin, but if Google adopted Bitcoin, you might think Amazon would be very likely indeed to do so very quickly. As that activity, that linking activity, happens over time, what emerges is something like the causal structure of your domain, which in itself is an interesting artifact separate from the accuracy of the forecast. Next slide. Going to run through very quickly an example of how that works in the cybersecurity domain. We have a question on the number of data breaches in the US. And you could just adjust the forecast. Do I think it's more or less likely that there will be at least 250 data breaches? But if you notice here, it's linked to 4 other questions. 2 of them are about data breaches in a particular sector, finance or health. 2 of them are about cyber attacks on the electric grid. Next slide. When you make that forecast, instead of just adjusting the slider, you can, as I've done here, under the red number 1 bullet, assume the answer to one of those other questions. I have assumed that the finance question is going to turn out to be false. This is a scenario, it's a possible world. In that possible world, the market says the chance of my target question being true is 87%. I can adjust that conditional probability, and it's a conditional bet. If my assumption turns out to be incorrect, the bet is called off, and I neither gain nor lose points. If the assumption is met, then it's a forecast. All right. Underneath, the fundamental advance that has let us relate questions and allow forecasters to relate questions on the fly is the system builds a Bayesian network. And that network does Bayesian inference to keep all of the probabilities coherent in this joint probability structure. So now, the forecast you see on this question reflects changes not only here, but to those 4 linked questions, if the change was big enough. And with the next slide, we can see that indeed some of them are. SciCast lets you see who made what forecast, which is interesting information to explore. In this case, you can see the current forecast is 45%. It was made by Prieur, who reduced it from 61%. But that 61% is grayed out because that was not a forecast on this question. It was a forecast by Market Snodsbury on another question, which had the effect of changing this question's probability by 7 percentage points. That sort of conditional capability raises the possibility of saying, what will the outcome be based on our actions? If we were to go into cybersecurity, we might ask, what would our time to detection be based on taking each of several available options? And then perhaps management would choose the one that the market estimates to be the most effective. That's the end of my introduction to SciCast, prediction markets, and this new kind of conditional or combinatorial market. Lamora, are there any questions?
Well, there is one from our audience, and thank you so much for bringing the questions in. The question is this like IARPA's Good Judgment project?
Yes, it is. We started funded by the same program that was funding the Good Judgment project, and we were doing geopolitical forecasting for 2 years. They did a phenomenal job. We also beat the baseline, the thresholds, though not quite as successfully as they did. But we and the sponsor felt that our conditional market, which was brand new technology, might do better in science and technology forecasting than in geopolitics. So we were moved over to geopolitics.
Thank you.
Sorry, moved over to science and technology.
Okay, thanks. And the reason, so another question that I have as you were speaking, I'm thinking about how this translates and how this is used by corporations and government agencies. So can you, if I'm a business person listening to this, how would I make use of SciCast's format to get questions to particular issues that I'm faced with? What are some ways I should think about this?
I think the most powerful way is like the last example I gave. Because you can relate questions to each other, you can include outcome measures that you care about, whether it's stock price or shipment date or price or product price or quantity or quality, and then relate it to several actions you might take.
Okay.
The market can link those actions.
Please continue. I didn't mean to cut you off.
Yeah, the market, which could be people in your company, it could be people external to your company, can then decide which actions are likely to make a difference and make quantitative estimates of how big a difference they think those actions would make. And that can be very powerful information to management.
That's wonderful. So you can use, the people who can respond can be anybody. They don't need to necessarily be forecasters or people who are experts in the field. You can actually bring this to your people within a corporation, and you would get that collective mind understanding, and they'd be able to give you some crowdsourced information.
That's right. It's up to the organizers. SciCast is open to everyone above 18, but Robin in particular has fielded prediction markets inside companies.
Okay. And one last question. How granular can you get, and then how expansive can you get? Are there parameters that we need to keep in mind as we're thinking about how we would want to employ the SciCast methodology?
Yes. We pioneered a type of question that lets you forecast a continuous quantity, but you give up a little information on the probability distribution to do that. But if all you care about is the average price or the average quantity, then you can be very fine-grained indeed in our market. Otherwise, you tend to have to put things in bins or buckets, and more than 5 or 10 of those becomes very awkward for your forecasters. The ones who manage it do it by running scripts. This is a good time to contrast with TechCast again. A prediction market really needs to have very clear, definite resolutions. And so it is hard to ask general questions about a long-term adoption rate because the forecasters are looking for a return on their investment. And if they might make 100 points on a question resolving in a month and 100 points on a question resolving in a year, they're going to put most of their resources into answering the near-term question.